Hey guys! Welcome to Budding Genius Academy. My name's Amelia. I'm a student at the University of Toronto where I am studying math, and I've been a math tutor for about 4 years now. So I really love learning math, and I hope that you guys do too, because I'm really excited to teach you guys something new today. If you like what you see in this video and you want a little bit more of that, you can go online to our website at bg-academy.com and sign up for some summer camp classes, or if you prefer, you can sign up for some one-on-one tutoring sessions as well. But either way, if you get the questions right on the quiz that's at the end of this video, you can send an email to the email address that will pop up then for 20% off of any lessons that you decide to book, either the summer classes or the tutoring. So let's hop into the video today so that we can get to that quiz at the end. So the video that we're talking about today is going to be on quadratics, and this is going to be part one of a series about converting in between different forms of quadratics. So make sure that you maybe subscribe to this channel so that you can follow along and see the other parts in the series when they pop up. The topic that we're going to be covering today is how to convert between standard and factored forms of a quadratic. So some of you may have heard about quadratics before, some of you may know the three forms of quadratics, but for those who don't, let's do a little bit of a review. So what is a quadratic? A quadratic is anything that has an unknown value that is to the power of 2. So right here, we can see it right here. The unknown value that we chose to use in this case is x. X will always just remain as x. These numbers a, b, and c just represent real numbers. So we could set, a equals 1, b equals 7, c equals 12, or whatever we want. But those x's will always just be an unknown variable. And it'll depend on what you decide that y is going to be. And vice versa, the y will depend on what the x is going to be. But what makes it a quadratic is that the highest power of x is that it's being squared. So there's one other x here, but it's only to the power of 1. So it's not being squared, so we don't have to worry about this being any higher than a quadratic. So what's a standard form of a quadratic then? Well, the standard form of the quadratic is this style, which takes this specific form, where the powers of x decrease every single time. So right here, we can see that the power of x is x squared. And right here, the power of x is x to the power of 1, which is just equal to x. And right here, it doesn't really seem like there's an x here, but we could think about this as x to the 0, because anything to the power of 0 just equals 1. So c times x to the 0 would just equal c. So the powers are decreasing every single time, and that is what makes this a standard form of a quadratic. Now, when you write out the standard form, you can also include a coefficient on every x. So in this case, we have that to be the a, the b, and the c. And these coefficients will just be real numbers. Alright, so I've got a little bit of a question for you guys. Of these three down below here, 1, 2, 3, which of these are quadratics? And which of these are in standard form quadratics? Alright, so think about it for a second, pause the video if you want to, and then we'll take it up in a sec. Alright? Okay, I hope you guys have your answers for which ones you think are quadratics, and let's go through. So the first one we see here, it has those powers of x. This is x squared, this is x, and then this is just equal to times 1. So those x's are present. It has a coefficient on every single side. It has a coefficient on every single x, I'm very sorry. And it's equal to a y. So this shows a relationship between the x and the y. So when you set x equals 1, then y will equal something. So this is a quadratic. Correct. Check. This is a quadratic. Now let's look at this next one. It does have all of the coefficients. It does have powers of x's, but this right here is only x to the 1. So the highest value of x is just x to the 1. So this is not a quadratic. We could almost simplify this to say 2x plus 7x just equals 9x, so this would be 9x plus 3, which is not a quadratic. So this is not a quadratic. Alright, and on to the last one here. So we see it has those powers of x that decrease every single time. It has its coefficients. There's a coefficient of 1 here because 1 times x is just x. But it's equal to a 0. Now, this is a little bit tricky because when this is equal to a 0, it means that you set y to equal 0. So this isn't a relationship between x and y. You've chosen one y, and there will be only one x that will be the possible answer. Or there may be more than one x, but there will be a set amount of x's that are the possible answer. So this doesn't show a relationship that you could plot on a graph. This is just a single point. If you consider all these other functions, like this function over here, to be on a graph, it would look something like this maybe. This would be just saying, well, I want y to equal 0, so here we go. This is the answer right here. It's not a graph. So it is in standard form, but it's not necessarily something that we want to be talking about today. All right. Now let's move on to factored form. So what is factored form? Well, factored form takes on a slightly different form, but it's the exact same style of equation. So it takes on this form here where you segment it into smaller multiplications of x that is just solely to the power of 1. So you have x to the 1 plus or minus some number. So in this case, we called it b, so b could be anything. B could be 2, b could be 37, b could be anything. And then you multiply that, because when you have two brackets next to this, the same as multiplication, you multiply that by another. And now this one might be confusing about whether or not this is a quadratic, because it doesn't look like there's any x's to the power of anything more than 1. But when we get to actually multiplying this out, which I'll show you how to do in a second, then you'll see that when you multiply an x to the power of 1 times another x to the power of 1, that equals x squared. So this is in fact a quadratic. Alright, same as we did above. I want you guys to, you can pause the video for a second now if you want, but I want you guys to think which one of these is a factored form of a quadratic. Alright? Alright, I hope you guys have your answers, so let's start. Let's look at this first one here. We have two values of x that are being added, or in this case subtracted, by certain numbers. They're being multiplied together, and there's a coefficient on the whole thing that would change every coefficient evenly. So yes, this is a quadratic. This is the factored form of a quadratic. It takes the perfect form. In this case, it's exactly the same as the form that we give, where a equals 2, and b equals 3, and c equals 4. So yes, that is a factored form of a quadratic. How about this next one? It has two powers of x. That's true. They're being added or subtracted by certain numbers. That's also very true. And does it have this beginning number right here? Well, we can't see one, but remember that these are being multiplied by each other. And anything, so x times 1 is just equal to x. So we could treat this right here as it having a coefficient of 1. I don't know if you guys can see that super clearly. But that means that yes, it has a coefficient, yes, they're being multiplied, so yes, this is the perfect factored form of a quadratic. Alright, and now on to the last one. This one might be a little bit tricky, so really think about it, but does this follow the form that we've checked all the other ones to? Well, it has one power of x right here, and it has another power of x right here. But you're asking maybe it isn't being added or subtracted to anything, right? Well, we could maybe rewrite this as 3 times x, right? Or 3 times x plus 0, right? Because x plus 0 is just equal to x. And then that also multiplied by x plus 1. And that looks a lot more familiar to our previously established factored form. It has a coefficient, it has two powers of x's right here, they're being multiplied together, so yes, this is the factored form of a quadratic. Alright, now that we've got that underway, how do you convert from something that looks like, from something that looks like this to something that looks like this? Well, let's go. So to start, we're going to talk about going from factored form to standard form. And then we'll talk about going the other way around. But going from factored form to standard form. So we start here with factored form. Oh, sorry, that was supposed to be a highlight. We start here with factored form. And to get from factored to standard, we use the concepts of what we call the FOIL method. And FOIL stands for first, outside, inside, last. So what that means is when you're multiplying two things together, two mini equations together, we could maybe call them, the proper way to do it so that you have the right answer is you multiply the first together, so the first in each mini equation. And let me make that. The first in each mini equation, and then the outsides, so the farthest outside, so this one and this one, and then the insides, so the ones that are in the inside of the equation, so those two, and then the last, so the last one in this equation and the last one in that equation. So if we were to use it with just these generic numbers, it would be the first, so x times x, which as we said earlier, x times x is just x squared, times the outsides, so x times b, right, where b is just some number, so plus bx, times the, plus the insides, so a times x, right, plus the lasts, which is just a times b. And we can see in these two middle ones right here, we can factor out an x. So this can be equal to x squared plus b plus a x plus ab. And that might be a little bit confusing because it's, which ones are x's, which ones are a and b. So let's do a practical example altogether, all right? So this equation we have here, y equals 2 times x plus 1 times x plus 2. So the first step is to do that FOIL method, right? And we do have this 2 right here. And that might be a little bit tricky to deal with because we know how to do FOIL for 2 equations, but we don't know how to do it for 3. So let's keep the 2 until the very end and then just worry about these 2 being multiplied together first. Because you can do multiplication in any order, right? 2 times 3, oh, that's a weird 3. 2 times 3 equals 6, and 3 times 2 equals 6. So we can choose to do this in any order, and it'll still be true. So let's focus on the last 2 first, because they're the most complicated, and then we'll worry about the 2. So we apply our method of FOIL. We go first, x squared, outside, right? X times 2, so it's getting added because there's no negatives, plus 2x, and then inside, plus 1x, and last, 1 times 2 is just 2. And then we can simplify this a little bit because there's an x here and here, so we can factor those out, and we can say 2 times x squared plus 2 plus 1 is 3, right? So plus 3x plus 2. And then we can take this 2 and multiply it into every coefficient in the equation using the method of distribution, which you may have heard about before. So this becomes 2x squared plus 2 times 6. 3 is 6, so 6x plus 4. And there you go. There's your answer. See? So now this is in the style of standard form that we saw before, right? So that's how you go from this factored form to this standard form right here. You just factor everything out, you make it a little bit longer, and there you go. So I have an example for you guys to do, and why don't you give it a try, all right? So pause the video right here, you test it out for yourself, and then we'll take it up together, all right? Ready? Pause. All right. Hopefully you guys gave it a little bit of a test for yourself, because that's the best possible way to learn it. But if you didn't, or if you just want to take up your answers, let's go through it together. So the first things first, the same thing we did with the question above, we have a coefficient on the entire equation right here, and we don't necessarily want to have to deal with it right away because it could be a little bit messy. So we'll just keep it to the outside, and then we'll multiply it into everything at the very end to make it as easy for us as possible. So we're going to focus just on this part of the equation right here. Sorry, that was a bad line. Just on this part of the equation right here without the 3 to start. And we're going to do that using the idea of FOIL. So let's go to it. The first in each equation, right? First. Those are those two x's. X times x, x squared. Easy. First, outside is the outsides of the equations, x times 2, but you got to be very careful, right? Because it's not 2, it's negative 2. So it becomes negative 2 times x, which is just negative 2x, so you have to put a minus sign, negative 2x. And then inside, right here, 4 times x, right? Nope. It's at negative 4. So you gotta watch out for that. Negative 4 times x is just negative 4x, so you write negative 4x. And then last, which is again negative 4 times negative 2. Two negatives make a positive, so it becomes positive 8. And then we can clean it up a little bit because we have some x's in common in the middle here, so why don't we smush those two together? So 3 times x squared, negative 2x minus 4x becomes just negative 6x plus 8. And then the very last step, we take that 3 that we have here and we multiply it into the coefficient of everything in the equation. So it becomes 3x squared minus, 6 times 3, which is 18, x plus 3 times 8, which is 24. And there you go. We converted from that factored form to the standard form of the equation. Very well done. Alrighty. Now let's move on to going the other way around. How do you go from standard form to factored form? So if you're given a equation in this form right here, and you want to convert it to this form right here, how would you go about doing that, right? Well, the concepts of it is basically the same as what we did before, but we want to go backwards, right? So when we were looking at this question before, for example, when we did this practice question at the very end, right? We went from two numbers that looked the same. Let me do that in a different color actually so you guys can see. We went from two numbers that both had an x on the end, and then we smushed them together, right? And we also know that those two numbers were the lasts in the equation. So those two numbers were multiplied up to make this number right here. And if we look up here, we can see that that same thing happened here, right? These two numbers at the end, right here and right here, were added up to make 3 here. And they were also multiplied because they were the last in FOIL to make this number right here. So that is the core idea of what we want to work with when we think about going from standard to factored form. So we want to find two numbers, and in this case I called them N like nut and M like monkey, which might get a little bit confusing because they sound very similar. And we want those two numbers to add up to this B and multiply to make C, right? Because that's how we go from this way to this way. So when we're going back the other way, it would make sense that we have to find those two N and M. So if you think about the equations, we have to find two numbers where n times m equals c, because that would be the L in FOIL, right? That would make the very last number. And n plus m equals b, because that b comes from the coefficient of x, and we know that using FOIL, there's right here n times x, and right here is m times x. So there's two numbers that have an x on them that we smush together. So that might also be a little bit confusing as for you guys, so I will go through a couple of examples together, and then you can try it once on your own, alright? So this first example that we have here is y equals x squared plus 7x plus 12. So we're trying to find two numbers that add up to 7, and multiply to make 12. So why don't we start by thinking about what numbers add up to 7? Well, 0 and 7 do, right? 0 plus 7 equals 7. But does 0 times 7 equal 12? No, right? So it can't be 0 and 7. What else? 1 and 6 add up to 7, right? 1 plus 6 equals 7. But does 1 times 6 equal 12? No, right? Because 1 times 6 equals 6. What else? 2 plus 5, right? 2 plus 5 equals 7. But does 2 times 5 equal 12? Nope. 2 times 5 equals 10. And how about 3 plus 4 equals 7? And does 3 plus 4 equal 12? Yeah, 3 plus 4 equals 12. So, there we go. We have two numbers that have added up to 7 and multiplied to make 12. So, we know that if we go back up here, this step that we did, if we're going backwards, the step that we did to go this way means that we have to split that middle number right here back into those two numbers. So we'll go back down. So we can say that y equals x squared plus 3x plus 4x plus 12, right? Because 3x plus 4x equals 7x, so we haven't changed the equation at all, we just split it. And now we can start pulling out things that belong to certain numbers. So we can see right here, this and this both have an x in it, so we can factor that x out. So we can say x comes out of it, right? And then we're just left with x plus 3. And then here, 4 and 12 can both be multiplied by 4, so we can pull 4 out of it. And so we have 4 out, and then 4x divided by 4 is just x, plus 12 divided by 4 is just 3. And now we can pull, now we can pull out an x plus 3, because that's a common factor of both of them, right? So we can say x plus 3 and x plus 4. And there we go. Sorry, it's a little squished, but that's the final factored form, right? We made it. The coefficient, as it was before, is just 1, and we have two numbers that are made up of x's, two little mini equations that multiply to get this standard form right here. So that's how you go from standard form to factored form. And so that may be a little bit confusing, you guys may be a little bit confused, but just in case, we'll do another one just to practice, and then I think you guys might get it a little bit more. Alright, I'm going to erase this a little bit so that you guys can see the difference here. So if you want to copy this down, maybe take a screenshot or come back to this video in a bit, or pause it. So I'm going to just erase this part right here so you guys can see. So we're back with this new equation, x squared plus 10x plus 25, and we have to figure out what two numbers, right, n plus m, add up to 10 and multiply to 25. So n times m equals 25. So why don't you guys think about that for just a second, and I think if you think about it for a little bit, you'll be able to get it. But we can go through some of the options. I'm not going to write them all out because there's more than there were when there were 7. But if we think about it, what adds up to 10? 0 and 10 does, but anything times 0 is just 0. So it doesn't equal 25. 1 and 9 do, but 1 times 9 is 9, right? 2 and 8 do, right? But 2 times 8 is 16, so that's not it. 3 and 7. 3 times 7 equal 21, so that feels a little bit closer, but again, that's not 25, right? 4 and 6, we're almost there, right? 4 times 6 equals 24, which is almost 25, but not quite. And 5 plus 5 equals 10, and 5 times 5 also equals 25. So we have our two numbers, right? N equals 5, and so does m. Because 5 plus 5 equals 10, and 5 times 5 equals 25. So why don't we go through some of these and make sure that we can get to that final factored form. So we have to split the equation originally. So x squared plus 5x plus 5x plus 25, right? That's where we're at. We haven't changed the equation at all. It's still perfectly valid for us to say it in this way. We've just split the 10 into 5 and 5. And now, the same as we did above, we see that we have an x here and we have an x here. We had a 5 here and we have a 5 in here. So we can factor those numbers out. So factor out that x of the first two, right? And you have x, because x squared divided by x is just x, plus 5x divided by x is just 5. And here we can factor the 5 out. So 5 times 5x divided by 5 is just x. And 25 divided by 5 is just 5, because it's 5 squared. And now we can factor this x minus 5 out of both halves of this addition. So we can say x plus 5, and factor that out of, and what's left is x, and right here, plus 5. Or, because these are exactly the same, we could rewrite this to say x plus 5 squared, because something times itself is just equal to that thing squared. So there you go. That is a perfectly valid factored form. Again, the coefficient would just be 1. And that's a perfectly valid way to go from this standard form right here to this factored form down here. All right. So this last one I'm going to leave up to you guys, and then we'll take it up at the very end. We'll go over it quickly. So why don't you give it a shot on your own. See if you can figure it out. Pause the video right here, and then we'll take it up in 5 seconds or so. Ready? Pause. 5, 4, 3, 2. Alright, I hope you guys did give it a bit of a try, but if not, or even if you just want to take it up, we'll take it up together right now. So, the same as all the other ones, right? It doesn't change. You're looking for two numbers, right? N plus m, which add up to 3. And two numbers, n times n, which multiply to 2. There are a little bit less options here, so we can go through them all together. So, to start, what adds up to 3? 0 and 3 does, right? But 0 times 3 is just equals to 0, so it's not 0 and 3. 1 and 2 do as well, right? 1 plus 2 equals 3, and 1 times 2 equals 2. So, there you have it, right? You have your n equals 1 and m equals 2. Here's something interesting to note, and I'll show you again at the sort of after we finish writing this, but if you switch these around, so you say n equals 2 and m equals 1, or you switch, like in the first one that we did here, you switched around the order of how we wrote out this. So if you wrote 4x plus 3x as opposed to 3x plus 4x, it'll work out exactly the same. It doesn't matter which order you write them down in. It should work out perfectly well. Sometimes writing them down in one way is easier than the other because factoring out makes it a little bit easier, but it doesn't matter which way you write them down. So anyways, back to the question that we have going on here. So we can say this equals x squared plus, and split that 3, right? So we'll split it into 1x, or x, plus 2x plus 2. And then we can go down to this next one and factor out the x's that we see here and the 2's that we see here that we have in common. So factor out an x of the first two, which is just x plus 1, right? Because the coefficient on this x right here is 1. And then, that looks a bit like a d. X plus 1. And then we can factor a 2 out of the second half of the equation. So we have 2, x plus 2 divided by 2 is 1. And now we can factor out that x plus 1 that we have on both halves of the addition right here. And so we say x plus 1, and what's left once we factor those out is just x plus 2. Just like that. And it works out. So here, I'll just show you very briefly. It'll work out if you do it the other way around as well. We'll go quick on this one because I don't want to take up too much of your time. I want you guys to have time for the quiz. But if you were to do this the other way around, and when you said x squared plus x here initially, and then plus 2, if you did it the other way around, so you said plus 2x plus x plus 2, it would still work. So you would have that same thing, you'd have an x in both of here, and it would look like you didn't have anything here to factor out, right? Because x and 2 don't have anything in common, but both of them are being multiplied by 1, if you want to think about it that way. So you could factor out a 1 from this equation, right? Because 1 times x plus 2 equals x plus 2. So this first one, you'd factor out that x, right? And then you'd have x plus 2 remaining. And then you could factor out a 1, and you'd have x plus 2 remaining. And then x plus 2, you can factor both of those out of the addition. So you'd have x plus 2 times x plus 1. And there you go. See? They look a little bit back to front, but because multiplication, you can multiply anything in any order and it'll be the same, these will be exactly the same statement. So there you go. I hope you guys got that answer of x plus 2 times x plus 1, or vice versa. And so, why don't we go through, I have a little quiz for you guys here. I will go through the questions on the quiz really, really fast, and you guys can test your knowledge. Alright, so why don't we start? You can pause the video. So ready? Pause the video. Alright, are you back? So that is how you convert between factored and standard form. So if you guys got all of these right on the quiz, you can email us down here and say, I got them all right on the quiz, for 20% off of any summer camps or any tutoring lessons that you book. And here's the email right here. It's buddinggenius@buddinggeniuscm.com. So I hope you guys really, really enjoyed this video. I love teaching it. And remember, this is just part 1 in a 3-part video series. So stick around, keep checking back in on this channel, subscribe if you want, and you can see the rest of these videos as they come out. Thank you so much for listening, you guys. It was really nice talking to you today, and have a wonderful day.